probably sinusoidal axis. The best answer, number 4, is probably sinusoidal axis, but we're describing. We're describing what's going on with the vertical translation. Okay, number 12. You guys just picked out your pieces, right? Solved for a period, and then you found your amplitude to be 1. How about number 18? Ready? 18. Period is 20. Yeah, period is 20. On number 18, sorry, and then amplitude is 2/3. Number 20, you can already tell there's a horizontal shift of, forget that F, that's a typo. That's a typo. Here, can I do that? There we go. Forget him. Y to the left because it's plus, yeah?
Yeah.
Whew. Okay, he's a beast. Hold on, let me zoom in just a little bit.
Oh yeah, that's where I lost it.
How about that?
You know, it's like when you feel so good in class and you look at it and you're like, whoa.
Wait, what's wrong? What happened?
This is so big.
Yeah, but what do you do though?
Well, okay, I got.
Okay. Wait, don't you just have it go up 2, down 2 instead? And then doesn't the period say it completes in half the time? So you can take a normal cosine, you make them go up 2, down 2, there are your handwriting lines, but then you squish it in to finish in pi. There you go. And then top, middle, bottom, middle, top.
Wait,
It only has a period of 1 of them.
why is the period 2 pi over b and then 2 pi?
It's 1 over b times 2 pi, which is 2 pi over b.
Oh, okay.
Because if you had your,
Yeah, okay.
they just went one step further and
So wait,
simplified.
can we like combine it then all the time?
Yeah, technically. The reason I do 1 over b is because that says the reciprocal of b, which is usually easier to think about than like having, yeah. So when b is a fraction, it's easier just to do 1 over b times 2. But either way. Now they went ahead and showed what the different key points were. They were being all snazzy.
Yeah.
So the top was the maximum, right? The middle was an intercept, the bottom was a minimum, the middle was an intercept, the top was the maximum. They just named them pretty. But other than that,
This messed me up. Period is like,
how long?
All
Period
of-
is how long?
yeah, but it, like,
Top to
cosine. Period would be just this. It's not this, right?
No, from top to top. One
Okay.
full cycle. Remember,
Oh.
cosine is like this, and sine is like this. One full cycle. Yeah, that would mess you up. You were thinking only half.
Yeah.
Yeah.
That's why.
Rena.
One thing that I get confused about is, so like, for example, the period was pi, so you would split that into 4 like pieces, right?
So hence the 1/4, 1/2, 3/4.
Oh, okay.
Okay, are we good-ish? On him? What's going on him? How high, how low? Well, just 1. But he's flipped, so it's going to look like bottom, top, oop, bottom, middle, top, middle, bottom, right? There you go. He's flipped to the normal one up there. The 4x, we'd have to find our period, which would be 1 over 4 times 2 pi, which would be pi over 2. So he's going to happen or occur in even less time. So if you notice this one completed in pi, the upside down one's going to complete in pi over 2. So he's going to have here and then halfway. He's a little baby one. He's been shrunk even more. So he's flipped, which means he's down. He's still just between 1 and -1 though. He didn't get stretched at all. He doesn't have a 2 in front like that one up there. And he happens in, the period for him would be pi over 2, so we have to cut that in fourths, which means 1/8. So you do another little tick mark and do 1/8, 1/4, 3/8, and then 1/2. He's a little squished one. Now why was this hard? I don't know, because you have to do 2 and 1. That was rough, right? 2 different sets of handwriting lines. They got a little iffy. But otherwise, you're just talking about what's happening. You're saying like, oh, hey, guess what? He got shrunk horizontally. He got even more shrunk horizontally. He got shrunk divided by 2 or times 1/2. This one got divided by 4 or times 1/4. This one with the negative got reflected. This one got stretched. That's all that stuff is talking about. Just explaining the transformations. But I know, doing 2 in one graph is kind of hard, maybe. And in years past, I've had kids that have been like, ugh, I don't want to do 2 in 1. They just did 2 separate graphs and compared them. That works too. That works too. Remember next one? Whew, it's big again. You go back to normal zoom. No. Where is he? There he is. This one, you're able to do just one function in one graph. You find your period by 1 over 4 times 2 pi, or 2 pi over 4, which is pi over 2. He's a sine, so he starts in the middle and he has to complete a whole cycle in 1/2 pi. Half of a half is a fourth. Half of a fourth is an eighth. So that's pi over 8. Pi over 4, 3 pi over 8, and then pi over 2. Middle, top, middle, bottom, middle. Does that work? And one more time, how did I figure out 1/8? What did I do? Okay. There was a start with our handwriting lines, etc. This needed to be pi over 2. And how do we figure out our quarter cycles? We have to cut it in 1/4, right? So what are we going by? 1/8. So we take our 1/2, we cut him in half, that's a fourth, and we cut him in half, that's an 8. And then we got top, middle, bottom. And that's how to count by eighths. So 0, 1/8, 2/8 is 1/4, 3/8 pi, and then 4/8, which is 1/2. We doing all right? This was a single graph. Okay. If you're having trouble with knowing where the x's are, remember, take the period, cut it in 1/4, and then you have to add it to wherever you're starting, which is 0 plus is really easy. 0 plus 1/8 is 1/8 pi. Number 68. Whew, finally one you got to do in your calculator, right? Did it work out all right? Were you in radian mode? Yeah, if you were in degree, remember we've had to do zoom trig, it would have been kind of messy. And number 76. We're getting close to the end now.
There.
This was one where you had to look at a graph, right?
Yeah.
Was that the messy one?
Yeah.
Right. Let me go get, I forgot to open up the book.
Because literally, you can just pick a point and then start from there. You consider that your A.
My kiddos that tried to get the book online, we're doing all right, right? You found it okay? Luca, what number was this? 70?
76 and 73.
Okay. That was the hard example we did in class too, right? Because we were doing 79. These aren't easy. Let me see if I can steal them and put them right next to the other guy. 76 is this one? Can I put him in here? Let's see. Aww. There. Okay, let's check them out. So, we're supposed to take this is the homework problem. We're supposed to take this question and we're supposed to get that information, right? Okay. Did they tell us it had to be a cosine? I think so, right?
Yeah. No, it's a,
You can just make any equation.
yeah, it's a cosine.
So,
I couldn't know because I didn't know where it started.
how do you find the sinusoidal axis first of all? You say how high, how low, and you figure out where the middle is. Well, if that's a distance of 2, right? Distance of 2. 1, 2. Question, where would the middle be? Yeah, just going 1 in between. So if that's -2, then where's this one at? Okay. So we know right away that d is equal to -3, because that's halfway in between. Now, once we figure out the halfway in between, then we just have to ask ourselves how high does it go and how low does it go? And we're eyeballing it because they didn't give us like actual points. But eyeballing it, it seems to go to -2 and go to -4, which means going up 1, down 1. So what's my amplitude? Does that make sense? So I always start by, especially on a graph, figuring out the very top, very bottom, dividing in half to get the sinusoidal axis, and figuring out, so dividing in half, it's 1, but where is that? That's at -3.
My fault. How do you find B?
Oh,
Out of the graph.
so once we have the D, and I would write it a little differently to that, it would be -3 plus 1 cosine of, now we have two more pieces to fill in, right?
Yeah.
Okay, I don't start with that, I start with this, phase shift. Where do we want him to start? We have options. Do you want to start at 0 and make it an upside down cosine? Do you want to start at pi and make it a right side up cosine?
The 0.
Or negative pi?
Yeah.
0? Okay. So let's plug in a 0, but if I plug in a 0, this cosine needs to be upside down, so what do I need to change up here? Yeah.
Negative.
Change the positive to a negative, right? So negative 1 cosine. Now I need to figure out the b. Now how do I figure out the b? It doesn't come straight from the graph. The period comes straight from the graph. So what does the period equal? Well, this one's a little hard to see, but couldn't we just measure from top to top? I know we're starting bottom, and that's okay, but I don't really see the bottom.
Looks like 2 pi.
Yeah, 1 pi, 2 pi. So we can say 2 pi equals 1 over b times 2 pi. What must be b? Yeah, b is 1 because it didn't change at all. Or you could divide both sides by 2 pi to double check and make sure the math tells you exactly what your brain hopefully shows.
So we can just pick a point for C.
Yeah, it's your choice. So it could have also been plus cosine x plus pi, which would have been pi left, or x minus pi, pi right. Because it cycles, right? So it's just going to start and go both directions. And so any of those are going to get the entire cosine. So there are more than one way to write the equation. There is more than one way to write the equation. All right, I agree. Those graphy ones were tricky, but does that at least give you a process or a reminder of the example from yesterday? All right, let's keep going to number 82 and 86, but let me zoom in just a little bit. What? Are you guys able to graph this puppy? You could graph that puppy. What they were asking is, when is cosine negative 1? And technically, you could have gone in your unit circle and said, hey, when is cosine negative 1? That's actually a deal. It's negative 1 right here, right? And who is that? So you can say, okay, if I go around 2 pi, sorry, just 2 pi, it hits at pi, and if I go backwards 2 pi, it hits at negative pi. So maybe you could have gotten this without even using a graphing calculator. But if you had used your graphing calculator, you would have graphed 1 as y1. You would have graphed, you would have graphed cosine as y1. You would have graphed y equals 1 for y2. And kiddos, if we're looking for when they're the same, what are we trying to find? What are these called again? Intersections, right? And our graphing calculator would have found us this intersection to be x equals 3.141592a with a negative. It's negative pi. So what would that have intersection been when you plugged it in your calculator? Positive 3.141592. Does that make sense? So you could have just used unit circle and said, hey, it happens at pi and happens at negative pi. Or, in this one, they actually expected you to use your calculator. They would have had to know 3.141592 is pi. 2 more. Dos más. 86. Can I make them bigger? There's the equation they got. I would have written the 2 plus in front. Remember, we write the d over here either way. And then number 90 was a lot like the example we did in class. Right? Wasn't that like super simple? Okay. Any quick questions on evens or odds? Real quick. We might not be able to answer all of them, but. Okay, not huge ones. Please feel free to come in during school or after, not during school, during lunch or after school.
How long are you till after school?
Probably at least 4:30. I'm going to go ahead and exit out and save that, and we need to go back to tangent and cotangent. Let me get to a single page so we can see it. All right, first of all, let's finish tangent. Remember, I said yesterday, wrong one. I said yesterday that tangent can be transformed. But remember, first of all, what's tangent look like? He looks a lot like an x cubed, kind of, right? His numbers are a little different, though. And what does he have ending the cycles? Vertical asymptotes. They're going to happen at every pi over 2 because at pi over 2 tangent, remember, at 90 degrees, right? Tangent is undefined in our square root of 3 over 3, 1 square root of 3, undefined, right? Undefined is at 90. So pi over 2 undefined, and then we have to go backwards 90 or negative pi over 2 for the other vertical asymptote. So what happens when stuff changes? Stink. My advice for graphing a tangent. Now I'm not going to make you go super detailed with tangent, not as detailed as sine or cosine, but there are some things that you need to have right. You need to figure out whether it's going this way, which is a normal tangent. What would make it go this way? If there was a negative by the tangent, right? Okay. You need to know whether it's this way or this way. And you need to know where to put the vertical asymptotes. So you know what's going on if it gets horizontally compressed or stretched. The vertical asymptotes will change, which means your tangent will get wider or will get narrower. There we go. And then you need to know the point of inflection, or the intercept. Okay, so how does this work? Finding the vertical asymptotes first. What we do is we take the argument of tangent, which is bx minus c, whoever that is. We take bx minus c, and we set him equal to pi over 2 plus, this is a little weird, but plus pi n. Do I want to make it that complicated? I don't want to make it that complicated. Never mind. Just do pi over 2. We're going to do the period in another step. The period is how, once you get one vertical asymptote, how far do you go to get another one? And how far back do you go to get like a previous one? So first you take whatever's inside tangent and say, you know what, buddy, whoever you are, whenever you equal pi over 2, we got some problems. Because that's where the vertical asymptote will occur. Kind of like for ln, when the inside argument equals 0, there was a vertical asymptote. Same thing here. When the inside argument equals his problem, which is pi over 2. How do you find the period? 1 over b times, what do you guys think? 2 pi was sine cosine. So for tangent, what's his period? Just pi. Or, if you like it, you could do pi over b. It probably depends on the situation as to which one you're going to use. So to find the vertical asymptotes, bx minus c equals pi over 2. To find the period, 1 over b times pi, and that tells you how far away to put the next vertical asymptote from the first vertical asymptote. And then to find the zeros, or I should say probably the points of inflection. Let's see. To find our first 0, let's do it that way. To find our first 0, we're going to do 0 plus c over b. We could do that. That's our phase shift. We could do 0 plus c over b. Which, guys, what is 0 plus c over b? Exactly. So let's just do c over b. That's the first one. And how are we going to get all of our others? We're going to do c over b plus the period. And that's the same thing up here for the vertical asymptotes. This one is going to find our first vertical asymptote. And for our others, we're going to add the period. So really the key to getting lots of things is to find the period. And let me show you what I mean. Okay? First of all, for this one down here, we need to rewrite him. He's not quite in a nice form. So we can rewrite this tangent as y equals 0 plus 1 tangent of 1/2 times x minus 0. Okay, perfect. So question. Where is my vertical asymptote? Or actually, if you want to start, hey, where's my first point? Where's my first 0? Well, who's c over b? So let's put a point there. Haha. But now, if I want to go ahead and put a vertical asymptote, well, I need to find him next, right? So I have a point, but I don't know how wide or how narrow to put my tangent or make my tangent. So let's find our vertical asymptote. Vertical asymptote says, take the argument. Now, we could take him, but that's messy. What's another way of writing the argument? You can choose. I like him because he looks easier, right? So take whoever's inside, take the argument, x over 2, and set him equal to who? Who can't he be? There you go. Pi over 2. Remember, 90 degrees. He's our problem. Tangent of 0 is 0, so he's okay. Maybe times 2? What does x equal? Pi. Okay, so I'm going to have a vertical asymptote at x equals pi.
Can you just have figured it out? Because it's like, it has to equal pi over 2 and x over 2.
Yeah, you could think of that, and it has to be pi. That's just a good shortcut. So I'm going to go ahead and go over pi, right? So I know at pi there's a vertical asymptote. But now I need to know how spread out everything is, right? So that's my first vertical asymptote. What's my period? Well, maybe the first vertical asymptote gives you a hint, but the period is 1 over b. And this is why I like 1 over b times 2 pi. Sorry, times single pi. This is tangent. What do you do with 1/2? Flip them. So 2 times pi. Oh, so what's my period? 2 pi. And how do I use all of these clues to my advantage? These are the 3 clues I put in. Well, actually, I've only put in 2 clues. I put a 0 at 0. I put a vertical asymptote at pi. Now, what do I know? Okay. How far do I go to get another 0? Well, I just start adding the period. So 0 plus how far? 2 pi. Oh, perfect. Where's another 0? Well, why don't you go back 2 pi, right? Okay, so I'm adding 2 pi to get more zeros. Okay, how do I get another vertical asymptote? I add 2 pi. Where's that going to put me? 3 pi. And I subtract 2 pi. Guys, this is ripe. Ripe for what? Ripe for drawing a sketch. Now, technically, I guess we should look at this little number just a little bit, because if it's been vertically stretched, think about your tangent. If it's vertically stretched, wouldn't it be like a little bit higher and a little bit more distorted? If it was compressed, wouldn't it be like a little bit lower to the graph? It's never going to like switch. So it might get lower or more stretched. But this one's just, well, is there any stretch? No. This one's just going to be normal. And I'm not making you guys find lots of snazzy points. I just want the general graph of what he looks like. Does that sound good? As long as we have a few different pieces to him, and then just put a little arrow at some point. You can't draw all of them because there's infinitely many. As long as you have at least 1 0 and at least 2 vertical asymptotes, you've shown me 1 cycle. It's always good to put another cycle in there too. But do you see what I mean by find 1 vertical asymptote and 1 0, and then you can use the period to go ahead and count for the next 0 or for the next vertical asymptote, forwards or backwards. Does that make sense? And what's the only time it's going to do this? Is when there's a negative. A vertical reflection, right? Now, we were talking about cotangent. Let's go ahead and get his key characteristics down. And then his transformation is a whole lot like tangent. So we're going to go kind of fast. Cotangent. He's super similar, except cotangent is cosine over sine, not sine over cosine. So instead of having vertical asymptotes at pi over 2, he's got vertical asymptotes when sine is 0 instead, which is going to happen at 0, and sine is also 0 at pi. So at either of these places, 0 or pi. So at 0 or at pi.
Shouldn't he be like this then? Sideways?
No, not sideways.
Because if they cotangent would be undefined.
Cotangent is the reciprocal of tangent. So when tangent was starting to grow, in a sense of, actually tangent's over here. When tangent, because he was growing this way, when tangent is growing, right, tangent's getting higher, cotangent, 1 over higher is actually getting lower. And then over here, where tangent was getting higher, cotangent's getting lower.
The 1, 2, 3 is going the other way.
So instead of going 1, 2, well, instead of going root 3 over 3, 1 root 3, he's going root 3 higher, 1 root 3 over 3. So he's going lower. And now, does he look a lot like tangent? Yeah, he looks a lot like tangent. What things are similar? It still only takes him pi to complete a cycle. So his period is just 1 pi. That's nice. Tangent, cotangent, both have periods of just pi. Vertical asymptote. It's a little bit different. X cannot equal. I'm going to put 0 plus pi n because 0 is the very first vertical asymptote. And then you add the periods to the right and you subtract periods to the left to get the next vertical asymptote and the next and the next. But you start at 0. Domain range. Oh, I cheated. I went a little too quick. VA at. So the domain means X cannot be all of those. And the range, well, he's all real numbers. Forever high, forever low. Just like tangent. Symmetry. This one's a little weird. It's not even. It's not even because otherwise this would be coming in the other direction. But actually it is going to be odd as well. Odd or origin symmetry. So you can go into tons of depth, but cotangent, super similar to tangent, but vertical asymptotes in other places, cotangent naturally goes down, whereas tangent goes up still with a period of pi. X cannot equal pi n. I just went ahead and did 0 plus pi n is pi. Okay, I just want to peek at the transformations, because that's basically the last bit that we need to know for section 4.6. Our goal was to finish, I know backboard is correction, still due Friday. 4.6 is technically due tomorrow, but I'm guessing we're going to do just a few more examples. Do I have some examples? Oh, we still have cosecant, secant. Yeah, we need another day on 4.6. I think the calendar has us having more than 4.6 actually. Ooh. So we're all right. So we're trying to get through cotangent today. Okay, you guys already got this, right?
You did
We only did the first one.
the x-intercept and the cotangent is at pi over 2?
Yes. X-intercept at pi over 2. And then pi away from that, which would be negative.
Cotangent is always also narrower.
No, still pi. Tangent was here, cotangent is here. So then guys, we're probably not going to get through writing all this down, but hold on. Has the process really changed at all for graphing transformed cotangent? I know it's up on the ceiling. Aren't we still finding vertical asymptotes first by taking bx minus c? But this time we're not going to set equal to pi over 2. What are we going to set it equal to? What's the first vertical asymptote? 0. So we're going to find the first one. And can you guys guess how we're going to find the others? Start from the first, and then we're going to add how far away?
Pi.
The period, whoever he is. Maybe he's pi, but maybe he gets changed. Okay? Finding the zeros. Well, the zeros, we're going to find our first one, right? By just doing c over b again. And then how do we find the others? We do c over b plus the period. Uh-oh, so what do we have to find?
Can you bring the screen down just a little bit?
The top says graphing transform cotangent functions. So it's just like the tangents. All right, kiddos. It's okay. We have a whole nother day for... Sorry, my computer just froze, so that's not working out well. There we go. We have a whole nother day for 4.6, but you technically have enough to get a good start on any tangents and cotangents. Now, secants and cosecants show up, just ignore those. We're going to do secants and cosecants tomorrow. So we'll start with doing one example of a cotangent tomorrow. Then we'll look at the last two. But to figure out cosecant and secant, you have to know sine and cosine. So if you did not do 4 or 5 homework for today, please, you're gonna make tomorrow so much harder if you go through today.
Bye, Misty.
Bye, guys. Happy Wednesday.
Can I come after school roughly?
Yes. Yes, you may.
I always say, we want to-
Probably in your